Okay, in this section, we'll talk about the problem 3 in homework 1. So before we start to answer these questions, we need to understand what the condition given by the plot and what the plot have and what the text try to give us what kind of conditions we'll have. So now we have two kinds of the digital signals, 0 and 1, and since there are only these two kinds of the input and output, so we can consider if one digital signal sent, that means the other digital signal won't happen. So there are two kinds of the complement event for other one. So now we suppose the event, there is an event A. That means if we try to send the transmitter try to send out the digital signal 1, and there is its complement event, that is the transmitter sends out the digital signal 0. And now we can suppose there's an event B. That means the receiver receives the digital signal 1, and the B complement is the receiver received the digital signal 0. But we don't. But when we try to read the questions, we don't know what exactly the possibility of B and B bar is. But we know that suppose the transmitter send out 0 with probability 0.6 and 1 with probability 0.4. That means the possibility for event A is 0.6, and the probability for event A bar is 0.6. Oh, this 0.4. And now we can mark here is 0.6, 0.4. And we also know the following conditions, that when the 0 is transmitted and the receiver receives 0, that means when the event A complement happened, the event B complement happened. So that probability can be denoted as B bar with A bar. A is 0.7. That is what here is meaning. And similarly, when 0 is transmitted and 1 is received, the probability for this one is 0.3. That means when event A bar happened, but received B, and this probability is 0.3. So that's what there happened. And similarly, when 1 is transmitted and the probability to receive 0 is 0.2, then the conditional probability for this one is when A happened, B bar happened is 0.2, and event B happened when A happened, the probability for this one is 0.8. And we know all these all these probabilities, and we know the definition for the conditional probability is as event A happened when B happened is equals to the intersection of A and B divided by the probability of event B. So now we can try to solve the problems now. The first one, find the probability that the data 0 is received. So this means we need to find the probability for B bar, which means the receiver receives B is. So to get a B bar, we need to find where the conditional probability is related to B bar, and we can see this one and this one. So the probability that can get to the 0. And we don't need to add the conditional probability together since they happened in different conditions. But for the whole event, we need to find the intersections that can cause the union that can where can cause the event B happened. So we can see that it caused by the intersection of the A bar and B bar, and also the event of the A and B bar. So which means the intersection of, so this means sending 0 and receive 0, and this one means sending 1 but receive 0. So we need to find these two the probability for these two for these two sets that can be received by the conditional probabilities. So the first one, sending B and receive B, that when receive B when sending B, that means the intersection of send send 0 receive 0 and divided by the probability for send 0, which means and we can refer to the probability for send 0 receive 0 is equal to the conditional probability here times the probability for A bar. It means, and this one is 0.7, and this one is 0.6. So the probability for here is 0.442. And this next, for the probability for sending A but receive B is equals to the intersection of send A but receive 0 divided by the probability for send 1. So it can refer to P A and B bar is equals to the conditional probability of B bar when it happened times P probability for event A, which is 0.2 times 0.4, and here is 0.08, and the event B is equals to these two intersections can add together, since there are only two ways that can receive 0. So add these two intersections together and can receive the output. So which means the probability B bar is equals to 0.42 plus 0.08 is equals to 0.5. Okay, for the second part, find the probability of error, which means if the probability that 1 is received when 0 was transmitted or 0 is received when 1 was transmitted. So we will use these two conditional probability to find this problem, since and these two conditional probability means when 1 is sent but we received B, when 1 is sent but we receive 0, and when 0 is sent but we receive 1. And for the whole set of the event, we will use the probability for the intersection of A B bar and probability for A bar B, and their union is our output result. What's the probability we have? So we still use the formula or the definition for the conditional probability as PB bar when A equals to P AB bar divided by PA, and it refers to the conditional probability for this one and times PA. So here is sending A bar receive B, but sending 1 bar receive 0 is the probability for the conditional probability is the conditional probability is times 2 is 0.2, and then times the probability that we send 1 is 0.4, that is 0.08 as the previous we calculated. And also another error when sending 0 but receive B is intersection of A bar B divided by the probability for PA, and refers to the probability payoff in the intersection of PA bar B equals to the conditional probability times the probability for A bar. It is sending 0 but receive 1, the probability for this one is 0.3, and the probability for the other for sending 0 is 0.6, and here the probability is 0.18. And so the union for these two is can add together as .8 plus 0.18 equals to 0.26, and this problem is done.